So let's take a look at your MT7, LT2, and 3 seminar. Do questions 1 through 6 to start with. We'll go over those in class, or you should do those just to make sure to get your brain warmed up for this lesson. What we're going to be looking at today are proving and using theorems about properties of parallelograms, but the diagonals of a parallelogram, and test to see if a shape is a parallelogram. Now we start here. A parallelogram is a quadrilateral, so we're moving into four-sided shapes now, where both pairs of opposite sides are parallel. That's the definition of a parallelogram. That is, you must have both pairs of opposite sides parallel. Now, because it's a parallelogram, we know a few things. And those things are, we know that the opposite sides, besides being parallel, we know they're congruent. We know the opposite angles are congruent. We know the adjacent angles add up to 180. So, for example, the measure of angle A plus the measure of angle B equals 180 degrees. We also know that if you have a parallelogram, and if one angle is a right angle, all the angles are right angles because we know the opposite sides are equal and we know the adjacent angles are supplementary. Now we can apply that on our first example here. I want to find CD. Well, notice CD is going to be the same as AB because we know the opposite sides are equal. Therefore, CD is going to be 4 feet. We can apply that in a proof. Notice the symbol for parallelogram looks like a rectangle, doesn't it? 4 sides. So if you have 4 sides, this means parallelogram. So I know all those things about a parallelogram. I want to prove that HJ is congruent to ML. So we start here with our 2 parallelograms. So I'm given that. And then we're told HJ is congruent to PK. Why is that true? Well, that's our first theorem. That is, we know the opposite sides are congruent. And we know PK is congruent to ML. Same reason. That's why I put them in the same line. And then, how do I know HJ is congruent to ML? Well, I'm just using the transitive property because I'm just going boom, boom, boom. HJ is congruent to PK, PK is congruent to ML, therefore HJ is congruent to ML by the transitive property. By the way, you do have to memorize these theorems. You do not have to, or you cannot make a formula sheet for these. That's part of the learning for this chapter. We have to know those reasons as we go through this. So that's why it's important for you to do your assignment, not to use an AI to do your assignment. It's pretty obvious when you do it. Okay, we have some theorems about the diagonals. If I have a parallelogram and I draw on the diagonals, I know the diagonals bisect each other. Notice the diagonals do not have to be equal. That's a different shape we'll learn about tomorrow. The other thing is, if I have a parallelogram and I draw on one diagonal, I know my triangles formed are congruent. I know, for example, triangle A, not ABC, that's not a triangle, ABD is going to be congruent to triangle CDB. Because remember, I know the opposite sides are congruent, so they know they match up. I know angle A and angle C are congruent. And since it's a parallelogram, I got alternate interior angles anyway. So I can see that I got various reasons, side, 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 angle, side, angle, 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 side, they all show up. Now let's apply that on our next example, which I think I'll do in the next video.